Hello everyone, welcome back to Prestige Academy's online lessons. This is Algebra 1, Class 8. Today we're going to go over combining exponents, graphing exponential functions, and then we're going to do some word problems that review everything we've learned so far. Alright, let's start with combining exponents. These are the rules you need to know when you have exponents you need to combine or you're doing questions with exponents. The first is the multiplication rule. It says that if the base numbers are the same, you can just add the exponents and keep the base number. Let's do an example. 2 cubed times 2 to the 4th power. Just keep the base number the same and add the exponents. 3 plus 4 is 7. So your answer would be this. If you have something like 2 to the 5th power times 8 to the 2nd power, you need to make the bases the same. Now 8 is 2 times 2 times 2. So there are 3 2's in 8. So you can just rewrite 8 as 2 to the 3rd power and then add the 2 power over here. And then you use another rule, which is right here. Power of a power rule. As you can see, we have a power over here and they have a power. This says that we can just multiply x and y, the two powers, and keep the base number the same. So this would be 2, 3 times 2 is 6, 2 to the 6th power. And then instead of writing this, we can write this, and rewrite the question as 2 to the 5th power times 2 to the 6th power, and then follow the multiplication rule. Keep the base the same and add the exponents. And that will be your answer. The next rule we have is the division rule. What if we're dividing two exponents? In that case, you do the opposite of multiplying. You subtract the two exponents. For example, 3 to the 2nd power divided by 3 to the 4th power. In that case, you would just do 3, keep the base number, and 2 minus 4, which in this case is negative 2. And in order to finalize solving that, we have to look at another rule, the negative exponent rule. If there's a negative exponent, you just take the reciprocal of it. You just switch those up, put it under 1. So in this case, this would be 1 over 3 squared. So if there's a negative, just put it under 1 like this. The next rule we have is the power of a product rule. This says that if we have two numbers like this, and we have an exponent outside the parentheses like this, then we can apply this 2 to both of these numbers and rewrite that as 2 squared times 4 squared. Now let's solve both of these to see if the answers match. 4 times 2 is 8. 8 squared is 8 times 8, which is 64. 2 squared is 4. 4 squared is 16. 16 times 4 is going to give us 64. So the answers match. And that's how we can check your answer. The next rule we're going to go over is the product of a fraction rule. Now, it's just like power of a product rule. When we have something like this, we apply x to both the a and the b. And we have something like this, we again apply this both to the a and the b. So 2 over 6, parentheses, let's go with the 3rd power. This is going to be the same thing as 2 cubed over 6 cubed. and then you can just solve that to get your answer. Then we have a zero exponent rule. You already probably know this. If there's any number and it's to the power of 0, you're going to get 1. And lastly, we have fractional exponents. Now this is a little more tricky, but you need to know this when it comes to simplifying radicals. If we have something like this, 2 to the 4/2 power, then we can just turn that into a fraction. The base number goes inside. The number on the top becomes the exponent of the number on the inside, and the number on the bottom goes outside. So this is going to mean the same thing as square root of 2 to the 4th power. And if we solve to the 4th power, we get 2 to the 2nd power, which is 4. I recommend doing practice questions and memorizing all of these rules because they're going to come in handy once you get into more complicated stuff. Alright, now we have a few questions that we're going to use these rules for. First, let's start with denominator. Just going to rewrite that. First, we need to apply this 3 to what's inside. Our rule right here says that we apply the x to for both the a and the b. In this case, the a is 2 times x to the 5th power, and the b is y. So when we apply this 3 to both, we're going to get 2x 5. We're applying 3 to that, and y to the 3rd power. Now inside this parentheses, we have 2 times x to the 5th power. And by the same rule, this time a is our 2 and b is our x to the 5th power, we're going to apply the 3 to both the 2 and the x to the 5th power, which gives us 2 to the 3rd power times x to the 5th power, and we're applying the 3 to that 2 times y to the 3rd power. Now we have here x to the 5th power to the 3rd power, and our rule right here says that we can just multiply those two exponents and keep the base number. So when we do that, we keep the base number, which in this case is x, and we multiply 5 and 3, which gives us 15. And then we can just carry the rest down. 2 cubed is going to be 2 times 2 times 2, which is 8. And that is our denominator. 8 x to the 15th power y cubed. Now let's look at the denominator. In the denominator we have 36 x to the 8th power y to the 6th power. And as you can see, we have different bases. One is x, one is y, and the other is just a number. So we can't use any of these rules. So let's write what we got for the denominator on top of the denominator and see if we can simplify it that way. We got 8x to the 15th power and y to the 3rd power. That's being divided by 36, x to the 8th power, y 6. And let's put our answers here. First, let's look at this expression. We have numbers on the in the front, then we have our x, and then we have our y. And we're dividing these. So we can use this rule. Let's start with our y's. Y cubed divided by y to the 6th power is going to be we keep the base the same and do 3 minus 6, which is negative 3. And then we can use this rule to get rid of this negative in front of 3. That's just going to equal to 1 over y cubed. And then we can put this in our answer. Top there's a 1, and in the bottom there is y cubed. Now let's do the x's. We have x to the 15th power divided by x to the 8th power. So we just do x 15 minus 8, which is going to be 7. Because this is just a positive exponent, just put that on the top so we can get rid of this 1, because 1 times x to the 7th power is going to be x to the 7th power anyways. And lastly, we have our numbers. We're going to simplify 8 divided by 36. Now you might already know what this is, but if you don't, let's do what we would do if we have more complex numbers. We would divide them by their common factor. In this case, you can start with 2. That would be 4 over 18 divided by 2 again. It's 2 over 9. Then you can just write 2 on the top, 9 in the bottom. And this would be your answer. We can no longer simplify it because these bases are different. One is x, the other one is y, and 2 over 9 is the most simplified form we can get. So this is the most simplified form of this question. Now we have a different example. Let's start by getting rid of the parentheses. We're going to use this rule for it, and this rule. As you can see, we're having this apply to both of these, both the denominator and denominator. So we're going to do first, using this rule, apply the x to both a, which in this case all of this, and b, all of this. So we can rewrite that as 60x to the 10th power, y to the 7th power, and all of them have the 2, and the bottom is going to have all of that, and then the 2. Then we can use this rule. Now in this case we have a number, the x, and the y, and the 2 is going to apply to all of them. It's going to be 60 squared x to the 10th power squared is going to be using this rule right here, 10 times 2, x to the 20th power. So x to the 20th power, and y 7 squared is by the same rule going to be y to the 14th power. So that's the denominator. Now let's do the denominator. 5 squared x to the 4th power squared is going to be 4 times 2, which is x to the 8th power, and then y 3 times 2 is going to give us 6. And then we can just focus on this. I'm going to get rid of everything and rewrite that. We had 60 squared x to the 20th power, y to the 14th power, divided by 5 squared x to the 8th power, and y to the 6th power. Now we can first start with simplifying these numbers. 6 squared is going to be 60 squared is going to be 3600, and 5 squared is going to be 25. And then we can just write the letters and the exponents back again. Now we can start by focusing on the y. And let's put our answer right here. Using the division rule right here, we know that we keep the base the same and do 14 minus 6, which is 8. So let's put that on the top. And then let's do the x's. X 20 divided by x to the 8th power is going to be x 20 minus 8, which is 12. And then we're going to simplify the numbers. I know both of those numbers are divisible by 5, so let's first divide them by 5. It's going to be 720 divided by 5. And both of these numbers, again, are divisible by 5, so let's divide 720 by 5. That's going to give us 144, and 5 is just going to cross out, so we can write 144 here. In this case, there's nothing in the denominator, so when we divide, our answer is just going to be this. Now let's move on to graphing exponential functions. Now, just like we had with the linear equations, which was y equals mx plus b, we're going to have a general equation for our exponential functions also, and it is right here. Now, there are rules associated with this that is going to make graphing exponential functions way easier and help you predict where the graph is going to be. The first one is the h. If h is positive, our graph is going to shift to the right. If h is negative, our graph is going to shift to the left. Now, the thing you need to watch with this rule is the negative sign in front of h. That negative sign makes it so that if you see something like x minus 1, the h is actually plus 1, positive 1. And if you see something like x plus 1, that means h is actually negative 1, because 2 negatives is going to make a positive. The second is the k. K is going to give us our vertical shifts. If k is positive, that means our graph is going to move up. If k is negative, our graph is going to move down. K is also, in this case, our horizontal asymptote. An asymptote is a line that your graph is going to get close to but never touch. For example, if our k is 2, our horizontal asymptote is going to be y equals 2. And if y equals 2 is right here, our exponential function is going to get close to it but never touch it. It's going to go to infinity. The next thing you need to keep in mind is the a right here. A is going to show whether it's going to be reflected over the x-axis, stretched, or compressed. If a is less than 0, you're going to reflect the graph over the x-axis. What this means is if you have a graph like this, and a is negative number, you're going to just mirror it along the x-axis. And if a is greater than 1, your graph is going to be stretched. And if it's between 0 and 1, your graph is going to be compressed. All right, this is going to be the simplest equation. It's just bx. Now let's graph this using a table. Starting with -3, then -2, -1, 0, 1, 2, 3. Then we plug -3 in, it's going to be 2, -3, which is the same thing as, if you remember from the previous slides, 2 to the 3rd power, like this. And that is equal to 1 over 8. When we plug -2 in, it's going to be 2, -2. Same thing as 1 over 2 squared, which is equal to 1/4. -1 is just going to be 1 over 2. Anything to the 0th power is going to be 1. 1 is going to be 2. 2 is going to be 4, and 3 is going to be 8. Now let's graph those points on our coordinate grid. -3, 1/8 is going to be 1, 2, 3, about here. -2, 1/4 is going to be a little higher than that. -1 is going to be half. 0 is 1. 1 is going to be 2. 2 is going to be 4. And 3 is going to be 8. And if you connect those lines, our graph is going to look like this. And that's how you graph these exponential functions using a table. Now, what if our graph had plus 2 next to it? In that case, that would be our k. And from the rules, we know that if k is positive, then our graph is shifting up. In this case, because it's 2, it's shifting 2 units up. So we would just shift all of these lines, all of these points 2 units up. For example, this was 1, now it's 3. This was 2, now it's 2 plus 2, which is going to be right here. And this was 4, 4 plus 2 is going to be here. And this was 1/2, it's going to now be 2/2. And all these numbers are going to get smaller and smaller as it goes. So our new line is somewhere like this. And that's just going to be the same thing shifted up. Now we have another example. Let's put our table in. And let's again start with -3, -2, -1, 0, 1, 2, 3. At -3, it's going to be -3 plus 1, which is going to be -2. So it's 2, 3 to the -2nd power. It's going to be 2 times 1 over 3 squared, which is 2 times 1/9 equal to 2 over 9. At -2, it's going to be -1, so just 2 times 1 over 3, which is 2 over 3. At -1, it's just going to be 0, so anything to the power of 0 is 1. 2 times 1 is going to be 2. At 0, it's going to be 1. 3 times 2, 6. At 1, it's going to be 1 plus 1, which is 2. 3 to the squared is 9 times 2, it's going to be 18. 2 plus 1 is going to be 3. 3 cubed is 27. 27 times 2 is 34. And 3 is going to be 4. 3 to the 4th power is going to be 3 times 3 times 3 times 3. This is 27. 27 times 3 is 2 times 1, and that's going to be 162. Now let's graph this on our coordinate grid. At -3, it's 2/9. Just like somewhere along here. At -2, it's 2 over 3. Somewhere over here. -1, it is 2. At 0, it's 6. And at 1, it's 18, somewhere over here. So we can draw our line like this. Now, is there a way to predict where our graph is going to be? Yes, we look at our h. In this case, our h is right here. So it says x plus 1. We know from our function that this is x minus h. So we know that our h is -1. Negative and negative is going to make a positive, like here. So our h is -1. So that -1 means that our graph, if it didn't have the +1, it would have been 1 unit over here. So if we were to just graph 2, 3x like this, without the -1, our graph would be just 1 unit to the right like this. So when we added that h, the +1, our graph shifted 1 unit to the left, and it was here. So if we want to simplify this process, we can just make a table for this without the +1. And first find the coordinates for this, graph that, and then just shift that graph 1 unit to the left because of the h. And if this number is more complicated and if there's a k next to it, you can just do it like that. For example, if we have an equation like, if you have a function like x plus 5 minus 6, for example, you can just make a table for this portion of it without the h and without the k, and then you can just shift whatever this graph is using the h and the k. All right, now let's do one with the k, like I told you in the previous slide. All right, I want to make a table for 2 times 3 to the x power. I'm just going to ignore my h and my k for a second. Let's start with -3 again. -2, -1, 0, 1, 2, 3. With -3, it's going to be 2 times 1 over 3 to the 3rd power, which is going to be 2 times 1 over 27. With -2, it's going to be 2 times 1 over 3 squared, which is going to be 2 over 9. With -1, it's going to be 2 times 1 over 3. It's going to be 2 over 3. At 0, it's going to be 2. This is going to be 1 times 2 is going to be 2. At 1, it's going to be 6. At 2, it's going to be 18. And at 3, it's going to be 34. Now let's graph this first. -3 is going to be 127, really close to the x but not touching it. At -2, it's going to be 2 over 9, a little bit higher than that, and then 2 over 3, and 2, and then 6, and then 18. It's going to be somewhere like this. Now let's apply our h and our k to this. This +1 means we're going to be shifting it 1 unit left. And this 4 means we're going to be shifting it 4 units up. So let's start with our dots, our points, and shift them. This is going to shift 1 unit to the left and 4 units up. 1, 2, 3, 4. So it's going to be somewhere like 1, 2, 3, 4. Shift 1 this way, right here. This is going to be again shifting 4 units up and 1 left. 1, 2, 3, 4, and 1 left. Be somewhere like this. And the next one again, 4 up. 1, 2, 3, 4, and 1 unit to the left. And then this dot is going to again 1, 2, 3, 4, and 1 left. 1, 2, 3, 4, and 1 left. So when we applied our h and our k, our graph is going to be right here. And that's how you graph this function and then add our h and the k to get your answer. Now we have a couple word problems to review what we covered in the previous classes. First, we have a system of equations question in a word problem format. Customer A is spending $188 on 7 candy bars, 11 books. Customer B is spending $236 on 13 candy bars and 11 books. How much does each item cost? And we're looking for their cost. So let's make our own variables here. Let's set T, X, the price of candy bars, and Y be the price of books. Now we know that customer A is buying. Let's first make it for customer A. Customer A is buying 7 candy bars. 7 candy bars, and he's going to pay X for each. So 7 times X is going to be the amount of money he pays for the candy bars. Plus 11 books. 11 times Y. And he paid 188. So we know these are equal to 188. Now customer B spends 236 on 13 candy bars. He pays X for each. And 11 books. 11Y equals 236. So our two equations are here. If you remember from previous classes, there are 3 ways we can solve this. First, we can find X, plug it into this, and solve it that way. We can graph these two, or we can eliminate if there's like a negative sign in front of it. And because I see 11 in both, let's do elimination. In order to do elimination, one has to be plus one number and minus one number, and these two numbers have to be the same. So I see 11 in both, but both are plus. So I'm just going to multiply the bottom equation by 1, both sides. So it's negative 13x, negative 11y, and negative 236. Now I can eliminate these two and just use the rest to do my equation. 7 minus 13 is going to be negative 6x. These are eliminated, equals 188 minus 236 is going to be negative 48. I can divide both by negative 6, and I will get x is equal to 48 divided by 6 is 8, because these are both negatives, the negative sign crosses out. So the answer is x equals 8. Now that we know what x is equal to, we can plug that into this equation and find our y. Seven times 8 is going to be 56. 56 plus 11y is equal to 188, so we can subtract 56 on both sides. 56. 188 minus 56 is going to be 132. And that is 11y is equal to 132. 132 divided by 11, divide both sides by 11. It's going to give us y equals 12. Now our question is asking how much does each item cost. So we would say 8 is the cost of candy bars and 12 is the cost of books. But pay attention to what the question is asking, because sometimes it only asks for one item and you can just leave it there. For example, if this question only asked for the cost of candy bars, we would just leave it as 8 and we wouldn't have to plug it in to find y. Now let's do another question. 2 kilograms of coconut juice, which costs $5 per kilogram, were combined with 8 kilograms of coconut milk that costs $3 per kilogram. Find the cost per kilogram of the mixture. So let's use an illustration to help us better understand this question. we have 2 kilograms of coconut juice and 8 kilograms of coconut milk. So if we were to make an illustration of this, we could just have 1, 2 coconut juice and 1, 2, 3, 4, 5, 6, 7, 8 coconut milk. And this is coconut milk, the other is the coconut juice. So as you can see, 8 plus 2, we have in total 10 units. So of the 10, 2 is juice and 8 is going to be milk. We know the coconut juice is costing $5 per kilogram, and our coconut milk is costing $3 per kilogram. For the coconut juice, there are 2 kilograms, so in total it's going to cost us 5 times 2, which is 10, and our milk is going to cost, there are 8 kilograms and each is $3 per kilogram, so 8 times 3, 24. So our total cost is $34 for 10 kilograms. If it's 34 for 10, get rid of all of this, $34 per 10 kilograms. We can do several different things. We can just divide 34 by 10 to get what 1 kilogram of the mixture costs. That would be the easy one. Or in case we have like more complicated numbers, we can do cross multiplication. In this case, let's do cross multiplication because sometimes it's not going to be as easy as 10 and you're going to have to do a lot more things after that. 34 for 10 is equal to what for 1? Cross multiply, 10x is equal to 34. Divide both sides by 10, x is equal to 3.4. So 1 kilogram of the mixture is cost $3.4. And you have to put the units, 3.4 as your answer. And that concludes today's lesson. Thanks for watching.